This week, this is week number 2 for 1/28/21, and this week we're working on scientific methodology in archaeology. I called this PowerPoint Archaeological Detective Work 101. But I like calling this one for students to invoke your inner Sherlock Holmes, right? As we learn how to do science in archaeology. So, were we invoking our inner Sherlock Holmes today? We got my deer stalker on, and here we go. Let's start with this. What is science? Science is a systematic study of the structure and behavior of the world through observation and experiment. What I mean by saying that is that science, for the most part, when you cut it right down to the nitty gritty of what it's about, all right, science is about measuring things. Science is a measuring stick. If you don't have some type of criteria to actually measure what you're doing in science, and you don't have science, all right? And that measuring stick could be anything. That could be a ruler, it could be a weight, it could be a composite amount of aggregate data, it could be anything. And once we learn how to do those things, once we learn how to actually measure things, then we're actually doing science. And that's what I want you to understand from this, all right? Because a lot of people, if you've had some type of scientific methodology, some kind of epistemological class on science, or right, the scientific method that you may have had in high school, you were probably taught things like falsification testing. In this class, all right, in archaeology, all right, that the entire way we do things is a little different, all right? Let's do some definitions. All right, deduction, the inference or of instances by reference to a general law or principle. What we mean when we say that is that 2 + 2 = 4. That we can infer from the premises of an argument, 2 and 2, the exactly what the conclusion will be, which will be 4. All right. In other words, mathematically, things add up when we the premises are going to ensure what the conclusion is. Falsification, the capacity or statement, a theory or hypothesis to be contradicted by evidence. What this means is, can you create a test for it? If you come up to me and you give me a hypothesis, are you able to come up with the capability of testing this hypothesis? Can it be falsified? And that's what we look for in aspect of hypothesis testing. Induction, the process of reasoning in which the premises of an argument support the conclusion but do not ensure it. What we're really talking about here is inference to the best explanation, or what we're talking about specifically is things that happened in the past will happen again in the future. It's through experience and logic that we're coming to our conclusions, all right? That's what we refer to as inductive logic. We see this being used quite most often in statistical tests. And that's the type of thing that I'm talking about when it comes to that. Abduction, the process of seeking the simplest and most likely conclusion for the given observations, meaning the simplest answer is the correct one, or inference to the best explanation we possibly can find, which is the primary way we do science in archaeology. And plausibility, the quality of seemingly reasonable or probable, meaning that is it the most likely scenario and the most likely conclusion of the variety of given conclusions that we could come from based on the evidence we have. Deduction, the inference of instances by reference to a general law or principle. The process of reasoning from one or more statements, premises to reach a logical conclusion. Deductive reasoning goes in the same direction that all the conditionals and all links premises with conclusions. If all premises are true and the terms are clear and the rules of deductive logic are followed, then the conclusion reached is necessarily true. This is the way you were taught in hypothesis testing falsification whenever you took any type of class on scientific method in high school. And that is absolutely true for the natural sciences, all right? And I want to make that absolutely clear. Falsifiability, the capability for a statement, theory, or hypothesis to be contradicted by evidence, all right? Like the argument that all swans are white. Well, obviously not all swans are white. All swans may appear to be white, but they're not all swans, white swans. That's why we talk about the black swan argument, that there's always going to be exceptions to a rule. All right. So whenever we're talking about falsification or falsifiability, what we're really saying is there a way to prove a given statement, a given argument, and show that this is absolutely true from point A to point B? This would imply the truth. This would imply a factual statement. And that's how you do deductive logic. Now, that's not to say that deductive logic is wrong, okay? But what you're about to find out, there are other ways of doing science than what we just do in the natural sciences, or what we commonly refer to as the hard sciences, as I said before, like physics and chemistry and all that. In the social sciences, we have a tendency to being unable to falsify hypotheses for the obvious reason that we don't own any bloody time machines. Hadn't got them. Don't have a time machine. We can't go back in time and check anything. I can't go back and say, am I right? The common aspect of anthropology is indicative of any sciences that work with people or are trying to divine and predict behavior, especially from a historical perspective, is that we're talking about things that are too vast and complex for us to do these kinds of things. Again, it would be incredibly impossible to falsify these hypotheses we're talking about. In other words, if I make a claim regarding a particular behavior of some population group that existed 10,000 years ago in the past, I don't really have a way to falsify that claim. For those of you who remember or had those classes in the past about falsification, the common method of the hard sciences to create a legitimate hypothesis, that cannot apply here. The foundation and deductive aspects of the scientific method is that you may have learned before creating a hypothesis and supported by testing won't work in this particular situation. So we're going to have to figure out a different way of doing it. And that is basically induction. Induction, the process of reasoning in which the premises of an argument support the conclusion, but they do not ensure it. A method where one's experiences and observations, including what are learned from others, are synthesized to come up with a general pattern that we can infer from. Deductive reasoning is distinct from inductive reasoning is distinct from deductive reasoning. While the conclusions of a deductive argument is certain, the truth of the conclusion of an inductive argument is probable, based on the evidence given. Within the social sciences, in comparison, we can lean on other methodologies to achieve what is basically the most plausible answer, which is not in any way less scientific. We do the exact same thing as our deductive colleagues, which would create a hypothesis as well. However, the assumption is that it's not necessarily supported via deductive reasoning, like some absolute mathematical proof, but one that is supported inductively, meaning that we can obviously demonstrate that this is the most probable or likely answer to the question at hand based on what we have done before. The best example I can give you regarding what I'm talking about is look at the formation of our solar system. Mathematically, I can provide you an exact answer as to when Venus will rise on the horizon on a certain night of the year due to my study of gravitational forces and mathematical calculations and whatnot. All right. This information, this conclusion, is deductive mathematically, as it is exact, and it can be replicated. But without that mathematical system to work it out, based on just observational information alone, I can also say I know when this event will occur inductively, based on what has happened in the past. Inductive logic is the logic that provides you an answer to a given question based on experiences and past observation. Now, believe it or not, we use this form of logic all the time in science. A great example of this, of course, is statistics. Stats is a form of math that provides you trends analysis of data that both understand the data and make predictions from it. Without stats, most sciences would not function, as they are for the most part dependent on it due to the sheer complexity of the data they're dealing with. Millions of moving parts in a given system does not lend itself well to absolute falsification in order to make predictions that you might need for what you're trying to research. And there are no scientific disciplines that are more complex with more moving parts anywhere than the study of human beings, namely anthropology and archaeology. Therefore, anthropology, especially archaeology, which is a subdiscipline of anthropology, we use inductive methodology like statistics to make arguments about a given challenge that we're facing scientifically. We realize that from both a historical perspective and the aspect of sheer complexity, it is nigh impossible to devise any test that's going to be definitive enough to argue we can falsify a given claim We were discussing the big questions as to human behavior. I like this particular placard from the author of the Sherlock Holmes series. We balance the probabilities and choose the most likely. It is a scientific use of the imagination. Hound of the Baskervilles. And he's also credited for the more infamous saying, if we eliminate all the impossibilities, whatever left, however improbable, must be the truth. And that is probably the best way I can put or explain what we do in archaeology. So let me go again a little bit into abduction. Abduction is the process of seeking the simplest and most likely conclusion from the given observation. A subset of inductive reasoning, abduction, is what we literally see Sherlock Holmes doing in that he calls deduction, but the author incorrectly, Sir Arthur Conan Doyle actually incorrectly says this, all right? It's actually inductive reasoning he's doing, not deductive. They actually corrected this, I find it funny, they corrected this in the new show Sherlock with Benedict Cumberbatch, all right? So it's kind of funny to me anyway that they updated the TV show, or right, from the original book series, where he constantly called it the Deduction of Logic, right? When actually the reality is what he's doing is called induction, or specifically the exact thing he's doing is called abduction. We refer to it in anthropology as inference to the best explanation. Instead of trying to establish justification or falsification, archaeologists attempt to establish a hypothesis that fit the given evidence. We refer to this as plausibility. What is the most plausible? Now, that's not to say that we do not or cannot use hard scientific methods along the way, because in archaeology we absolutely do. We use hard science probably more than any other discipline out there in the social sciences. Most of the things we'll be doing or discussing in this class that we're doing in class are 100% deductive in our approach. Like dendrochronology, for example, which counts the tree rings to get an exact date of when that tree was harvested, or carbon-14 testing, which uses an exact methodology to test the amount of radioactive elements in a given sample. The difference is how this information is interpreted once we have it and add it to the overall scope of our data. We use the hard scientific methods as our job, but our job actually as anthropologists is not just to stop there, but to take that information and use it to understand the behavior we're trying to research. Now, speaking of detectives, being a good homicide detective is something I know a little bit about myself. As a cop, and I did this job for 20 years, you have to have a variety of means at your disposal to solve a crime. A fingerprint, blood analysis, witness testimony, ballistics, bodily fluids, body fluid pattern analysis, any number of different things like this. But your job as a cop is not to run analysis, okay? Just like your job as an anthropologist or an archaeologist is not to do deductive methodologies, all right? Your job as a cop is to figure out crimes. Your job is to bring people to justice, all right, who committed those crimes. And the hard science in your job is just a tool of the overall job, which is catching the bad guy, if you can understand that concept. Archaeology is exactly like that. Much, if not nearly, all we do is knife forensic in our scope as well. As an archaeologist, you have a variety of hard tools at your disposal to understand and create analysis. But the job is understanding human behavior. And that's what you're trying to get to. You're trying to metaphorically catch a killer in the science of what we do. We use hard science, mathematics, observation, data collection in order to create a hypothesis about human behavior that is being supported by the data we have collected. And just like the cop on the street, the primary way we do this is not through the use of hard science, but through simple elimination. We use bare bone, good old-fashioned logic to get there. It's what the epistemologists call abduction. We commonly refer to as the inference to the best explanation, or your gut reaction to what you're looking at and what looks like the best possible answer to what you're trying to solve. Let me give you an example. This is the easiest one I can put it. 3 guys are in a sealed room. Okay? One of them is dead. And he's stabbed with a knife, and that knife is still in him. Time of death is 1 hour previous, and the room was locked from the outside during the time of the man's demise. Logic dictates that of your pool of suspects, you have only 2 possible scenarios. Either the person did it to himself, or one or both of the other individuals in the room did it to him. There's no third option. Unless you are planning on arguing something of the supernatural variety in archaeology, we don't do that here. Okay? One of these 2 that are in there with them, the third person is dead, has got blood all over him. All right? And you do a little background checking and find out the guy with blood all over him has a grudge against the deceased. And finally, the other guy that's alive in the room is a quadriplegic in a coma. So, simply put, it's not going to be very difficult to figure out, okay, who did it from the most plausible answer possible. But guess what? From a scientific standpoint of view, the hard scientific standpoint of view, deductively, you do not have a way to make that claim the guy covered in blood did it. You don't. This is also the reason why in our court systems we do not use the term deductive logic like that. We tend to use the notions of suspicion, reasonable suspicion, preponderance of evidence, and then beyond a reasonable doubt. All right. We do not say deductively proven. All right. We use logic in law the exact same way we use logic in archaeology in many ways. Because, you simply don't even even with all this information, there's still a tiny, small, infinitesimal possibility that the guy covered in blood actually didn't do it. But by employing simple logic, inductively, by inference to the best explanation, you as a cop are going to be arguing, the guy covered in blood, that is the most plausible explanation to understand what occurred in this room an hour ago. Am I correct? All the evidence leads there, all right? Beyond any real logical shadow of a doubt, this is what happened, all right? Even though I can't deductively say it, inductively, I can make that determination. And along with that, you'll be making trace analysis, forensic, looking at all the circumstantial evidence as well to make your case. But logically, what you will be presenting is the most plausible answer. That's what we do. We are attempting to get to human behavior through the deductive means to make an inductive argument about what it is that of human behavior we're trying to understand. So in effect, what we're doing is reviewing the material and based on both solid scientific procedure and what we've learned from the archaeological and historical perspective to attempt to understand the human behavior. We are doing more than just trying to figure out who and how. We're attempting to understand the why. Now, inference to the best explanation, aka abduction, is primarily what we do as an archaeological detective. Our research is trying to make a case, literally, for a hypothesis we think is the most logical and plausible argument regarding human behavior that may have occurred thousands of years ago in the past. What you're trying to figure out is what you think is the most logical explanation that interprets the data you have collected. In effect, you are an archaeological Sherlock Holmes, trying to provide the best analysis of what you think not only occurred, but why. That's the first half of the lecture. The other half I want to talk about is something that, for whatever reason or another, I don't think gets covered enough in whether it be the sciences, whether it be the social sciences or the natural sciences, either one. And this is the aspect of fallacies. And I'm going to give you in your assignment a list of logical fallacies, and you'll find it right here. Whatisyourlogicalfallacy.com. You can click on that link and it'll take you directly to it. You have 24 fallacies that I'd like you to familiar yourself with, all right, and understand what they mean, all right. Please peruse that. You'll find it here, and you'll also find it in your assignment that you're given this week. Oh wait, you don't understand what a fallacy is? Okay, well let's cover that first, all right. Per Purdue's Writing Lab, a place I'd also like to take a look at, and I've got a link for that as well in the assignment, because it'll teach you everything you need to know about academic writing. A fallacy is a common error in reasoning that will undermine the logic of your argument. Fallacies can be either illegitimate arguments or irrelevant points and are often identified because they lack evidence to support their claim. In other words, there is a syntax error in logic that's going on. That's commonly being coming here. We're talking about pill authority, no true Scotsman, ad hominem, things like that. These are fallacies that people make in argumentation, and unfortunately, they get used way too much, all right, and it muddies the water, and we're not having a good, productive discussion about anything we're trying to work at in regards to scientific endeavor we're attempting to do. So, therefore, we have to be very careful both in how we speak in class to each other, all right, and we have to be very careful about how we write our papers that we avoid these fallacies at all costs, all right? So, please let's make sure. And I'm going to go through, and I want you to read your logicalfallacies.com, take a look at it, all right? You don't have to memorize that or anything like that, but I do want you to look at five fallacies that I'm about to go over with you and explain and help. Hopefully, you'll understand them a little bit better as I go through them. So, flip through here. All right. The first one is an ad hominem. This is an attack on the character of a person rather than his or her opinions or arguments. An example is person A says, I think President John A. Smith is the greatest president this country's ever had. And then person B says, well, I think anyone who thinks thinks that stuff is an obvious Nazi, and based on that alone, you're freaking wrong, idiot. Well, the issue is not whether or not person A is actually wrong. Person A could be wrong. All right, there's not a argument. I mean, it very well could be. But person B did not make their case by what they said. All they said is they insulted person A. Insulting person A proves nothing or supports nothing. Absolutely. You cannot make any logical claims whatsoever based on that form of argumentation. In other words, if you're talking to someone in class and the person gives their particular opinion, all right, you cannot rebut their opinion by saying they're a butthead. Not going to work. All right, you have to rebut their opinion based on the merits of what they say. All right. Fallacy number 2: appeal to hypocrisy. This is playing the game of well, you too. In other words, instead of addressing an argument at hand, they say that the other side is just as guilty of doing the very thing you're pointing out, which does not in any way address the original issue. An example, person A says, you cheated on that test. Then person B says, well, but I saw you cheat on a test last semester. Well, the issue is not, again, there is not whether person A is wrong one way or other in this instance. Person B, instead of addressing the issue, decided to attack the person they were speaking to. Basically, calling the other person hypocritical for acting the same way in a previous instance. And the truth of the matter is they can be hypocritical. That is not a disproving argument. What is the issue here is the person being hypocritical does not dispute or disprove the aspect of what the first person said. The first person said the person was cheating on a test, and you did not disprove it by just simply saying they're being hypocritical about it. You still have the issue of the fact they cheated on the test. So therefore, that's a logical fallacy. You have yet to address the issue at hand. You have to address that issue. All right, number 3, logical fallacy. Ecological fallacy. This fallacy occurs quite often in both inside and outside academia. And as a whole, it's based on a common belief where to judge everyone in a group based on a single person, or to judge a single person based on the whole, or even a sampling of it, scientific or not. Okay, in statistics, it's fine to make arguments about the data you've collected in aggregate or the entirety of what information tells you about that group. But what it can't tell you in this vast amount of data, all right, is exactly what a single person can or will do within a group. Just can't do it. All right, this is probably one of the most worst mistakes I've seen overall in academia when people try to do this, inside and outside, because we say X is true about the entire group, therefore this one person will act like the entire group. Not necessarily true, and vice versa. We can make predictions, we can make arguments, but moving from the macro to the individual to the macro in making any argument is fraught with the worst possible errors one can imagine. Example, person A. I collated my data regarding school shootings, and based on my analysis and my predictive remodeling, I can say emphatically that Bob is going to be a school shooter. Obviously, this form of argumentation is never going to work, but unfortunately, we see it consistently and constantly in and outside academia all the time, and one could probably think of examples just off the top of your head where people do this, namely regarding racial or sexual prejudice. When it comes up in any way regarding prejudice, it's usually due to the person not only committing this fallacy, but also working with a data set, past experiences, how they've been taught, inborn cultural biases, etc., that isn't accurate in the first place. This also relates to individual biases that are not just morally reprehensive as well. Like, we have innocent assumptions occasionally, all right? But what you need to remember is that as we discuss any aspect of data collection in regards to complex systems, the individual is not necessarily representative of the whole, or vice versa. You cannot judge this single ball whole. And I'll give you a little corollary on that too as well. This also is an issue whenever you have an individual giving their own personal story. You have a person say, well, I have all this scientific data to back up this claim. And this other person comes along and says, well, I hear all your entire claims, right? But my personal story is different than what you said with your scientific claims. So therefore, my personal story is my personal story makes more sense to me. So, you must be wrong. Obviously, again, that's a fallacy. You cannot take one story of a given person, right, and say that negates all the scientific data that someone else has already collected about a whole thing. Same concept, all right? Number 4, naturalistic fallacy. This occurs when we make a logical leap. Let me move this over. Because these are the mother of all the fallacies right here. These are probably the most important ones, all right? And the guy you're seeing that picture right there is David Hume. He's the one that pointed these out. Naturalistic fallacy. This occurs when we make the logical leap that if something is natural, it must be morally, ethically, or naturally correct. The most common example we see is when people do this, when they make the argument that things come from nature, things are more organic. These things must be better for you. Well, I'll tell you right now, plutonium-239 is 100% organic, and I'll also tell you that it's 100% not good for you. All right. Another example that is common to say that those actions and states that we see in nature must be more correct, and then things and actions that seem to go against nature. All right. Again, this is another logical fallacy. Example, person A. Most cultures codify marriage for sexual relations between man and woman, and when we see that this most often in humans, that must mean that is the most moral way to act. Well, the obvious problem here is that state of nature does not define logically a moral or scientific argument, other than you just provide it as a data point. Okay? All it really shows is an observation. What we observe to be true or factual based on the whole does not mean that it's ethically, morally, or objectively correct. We can't define morals, ethics, and these things objectively like that, all right? These things you're talking about that should do. We only see it occurring. We can't make should arguments here. This is the conundrum that many people in science find themselves when they try to use science to make moral arguments, which will never be ever objective. And it directly relates to our last fallacy, all right, number 5, the is-ought fallacy, or the is-ought problem that David Hume talked about again. Simply put, this is a fallacy that exposes the major issue that with most of what I've discussed in the previous 4, that one cannot either A, claim that something is morally correct based on seeing it in nature, and B, claim to know what is morally true based on just making a should argument. Should or ought arguments are moralist arguments, and people tend to make make them based strictly on their own biases and assumptions. And they're always going to be subjective. When I say subjective, I mean they're based in a personal point of view and usually couched into an individual opinion. This is a common problem, even in the social sciences. We're filled to brim full of academics again, who are willing to tell you in no uncertain terms what someone ought to do or what is morally correct based on their own individual scientific research. The issue is, as David Hume talked about, that you cannot connect what one should do based on the observation of what is a scientific and objective manner. And you cannot assume to know even subjectively what should be done without ever knowing what exists in the first place. All moral ethical arguments are subjective, not objective, and it's simply not what we do or not what we can do logically within this given scientific paradigm in science. What you need to understand about what I'm saying is this. We are scientists, okay? If you'll remember from the movie, I think it was Indiana Jones and the Temple of Doom, right? He said, we deal with facts, not truths here. If you're interested in truths, the philosophy class is like 3 doors down. He'll be happy to have you. Same situation here. We make factual, objective arguments and collect empirical data to create hypotheses that support our contentions, either based on what can be falsifiable and then supported, or what is the best logical answer based on the available data, not what our personal opinions are. Your personal opinions are fine, and they're great, they're okay, whatever else, but that's not a scientific argument. If we wish to make arguments as to what is moral and ethical, we're doing it outside the realm of being a scientist. Furthermore, in corollary to what Hume said, if we were planning on making these subjective arguments, then we have to first know what it actually exists as scientists before we even start. When you are discussing issues dealing with social sciences, it becomes paramount in importance, as what we're talking about are systems, vast systems of data with billions upon billions of moving parts. It cannot get any more complex than human behavior and mass. So the notion that we can just change these things, or pass these laws, or all we need to do is get away from this form of economy or mindset or actions, these things are usually ludicrous arguments that aren't based in any form of scientific reasoning at all. All right. Now, it can be your personal opinion, and please feel free to have those opinions. All right. But as far as this class is concerned, those are not arguments that can be objectively supported and are not congruent to any form of scientific reasoning. Papers will be due on midnight of the 31st, January 2021, in the Dropbox on Canvas. If you have any questions, please email me or put one up in the chat, all right, so I can see it. And you guys have a great week, all right, and I will see you on Thursday.